Okay, so this is our second lecture. Our first lecture is an overview for this course. So this course is probability and statistics. So we say probability is the language for statistics. Okay, this this lecture we talking about probability. So how to find the probability? So the basic idea is just split whole into parts. So then we can have those probability question. What is the chance from this part? What is the chance from that part? So split whole into parts. We can split all by one fact. For example, like we split all people, students by gender, like a male or female. So we say we split it by one fact. So this is gender. So before we just have a male, female. Maybe by now we have LGBT. But anyway, so here just split by one fact. So we can have those questions. I'll pick one student. What the chance this one is female? I'll pick two. What is the chance this that both are female? So if we pick one or two, such a problem very easy. So if we pick many, like pick four, or pick five, pick four. So then we need to use this notation, right? So we call this the combinatorial coefficient. So from n, pick k, how many ways? So this way, n factorial or k factorial, n minus k factorial. So this number, so this 10 from 10 to 3, so we say this number means like 10 factorial, 3 factorial, or 7 factorial. So cancel 7 factorial, so this actually we can use this formula. This just multiply 3 number, we just start from 10. So 10 times 9 times 8, and the denominator we also multiply by 3 numbers, but those 3 numbers we start from 1. Okay, so we use this to do numerical calculation. So here 9 choose 4, so we multiply 4 numbers. So numerate, so start from 9, so 9, 8, 7, 6, 4 number, right? And the denominator start from 1, so 1, 2, 3, 4. Okay, so if we use this notation, then so the kind of problem of pick many, this is easy, right? So let's say, like, okay, so at first we say all students are all, so we split all into parts. So we totally we have 12 male and 14 female. So totally we have 26. So from 26 pick 4. So total way is just from 26 pick 4. So what the chance this thing happen? One female, 3 male. So then like from this part, from male pick 3, from this female pick 1. So from female 14. Okay. So such a problem so become easy. Right? Use this notation. Pick many. Okay. So then we can have those kind of problem like a little bit more complicated, but the basic idea is same. Let's say like an contains 10 balls, 4 red and 6 blue. So here we have 4 red, 6 blue. Oh, a second. Oh, so we have 2. This one, and let's say we put this as A, and that one is B. So for B, we have a 16 red one and the blue one we don't know, so put the X blue one. Okay, so from each we just draw one ball. So from here pick one, from here pick one. So here we know the probability that both balls are the same color is thus. So here if we know X, then we can have those probabilities from each we just pick one. What the chances the probability? What the chance that these two balls are the same color? So here we know the probability find X. So this goes same, right? So let's say there's a probability same color. So could have two cases. Could be like a probability both of them are red, or both of them are blue, right? So this probability equals 0.44. So how can find those probability? So from here get a red one, from here get a red one, so this get a red one is 4/10, right? And from here get a red one 16 over totally is 16 plus X. So plus both of them are blue ones. Okay, blue one is 6/10, and here's X over 16 plus X. So we get this equation, right? So this equals 0.44, so we can find this X. Okay. So we can also split all by two factors. So a typical example is just that we split all students by male or female, also by their grades. So here we have two factors. One is gender, male or female. We can split them by male or female, and also we can split all people by their grades. So some people got A, some got B, or C, or D. Okay. So then we can use this table to represent those information, right? Okay. So if we have two factors, then we have the conditional probability. Okay. So let's say PA, suppose like PA is a probability, suppose we pick one student, and we get what is the chance that we get a student? Oh, there's a probability. We also can understand there's a probability as a percentage for getting A. So this equal totally we have 50 students. We don't care male or female. And so totally how many get A? Get A with 8, right? So this so here we don't care male or female. So we just check those. We put male female together. We just consider grades. So what the chance? What is the chance to get a grade A? So then this one is a conditional probability, meaning we just focus on male students, focus on those students. Okay, so totally we have 20 of them. So among them, how many got A? It's 2, right? So conditional probability is just to consider this part. And we also can have this consider if so totally we have 30 female. If we here suppose we denote F as female, not grade F. Okay, female. And among them, how many got A? 6. Okay. So from here, we find, oh, probability got A. This is for all students. This is the probability for getting A for males, for this part, for male students. So those are probability for female students. So we can say that this is the percentage of getting A, grade A for all students. So for getting A for male students and for female students. So we find those 3 probability are not equal. So not equal, so we can say like a grade. Those things, and male, female, and gender somehow related, right? So in terms of probability language, we say these 2 factors are not independent. Okay, so if they're equal, let's say like equal, like PA getting A for all students, and check male for male student getting A, or for female student getting A, they're the same. So this means that getting A or do not get A have nothing to do male or female, right? So we say in this case, grade and gender is independent, not related. Okay. Okay. So so here let's say like we can separate students by male or female, and also we can separate by student by scholarship and no scholarship. Okay, so here we have 2 factors to separate all students. So we can use such a table. So so in fill out this table, so here we only know like for male, female, or 20 males, so they female. For scholarship, totally 20 have scholarship, 20 no scholarship. But in order to fill out this table, we need a more piece of information. So we need a little bit more information conditions. So the condition can be like many cases. Like here, if we know that among male students, 9 have scholarship, so we can put like for male like scholarship. We also use this no scholarship, right? So totally male 20 students. So for male, if we have 9 got scholarship, then this means 11 no scholarship, right? And so we can fill out the table. Because totally we have 22 got a scholarship, so then this for female should 13, right? And the here we also like let's say like among female students 30% got scholarship, so we can find how many female got a scholarship. We also can use this condition, like it says like what this means. Among ACE students, male count for 60%. So let's say total scholarship we have 22, right? Yeah, 22. So among the 22, we have male or female. So this means male count for 60%. So how many male got a scholarship? Should it be 22 multiply 0.6. So this equal 13.2, right? Yeah. So 13.2. So here, so cannot be 13.2, but mathematically we just do this, right? So if we have here 13.2, then we can figure out this. We can figure out this table, right? And here, let's say this condition m and a are independent. So how can we use this information? So independent, we say independent meanings like let's say we say like okay, like this means like gender and male. Let's say the scholarship. Male got a scholarship, and totally scholarship. If they're equal, then this means M and A are independent. Okay, so this is a definition. And also from here we can get this result. If this, in general, if A and B are independent, then we have this result, like A and B equal PA times PB. Okay, so here if M and A are independent, so what is this meanings? Meanings like M and A equal PM multiply PAs. So what is PM? PM is percentage for male. So percentage for male is 20 over 50, right? So this is 20 over 50. So what is the percentage for scholarship? I think I remember this is 22. So how many scholarship? We say we have 22, right? Yeah, 22 have scholarship. So this equal this probability, the M and S. So M and S is probability, so let's say equal. So here we need a little bit of calculation. Okay, so we know this probability, then we can find how many, let's say, male and female scholarship, no scholarship. So we can find this number. So this is M and S, right? So the probability M and S equals this. Then how many, what is this number here? How many male got a scholarship? So this equal probability multiply totally. So here we do not consider conditional probability. We say M and S is this probability. So here totally is 50, right? So this one should equal this probability multiply. So here 50. So here multiply 50, not 22, not 20. Should multiply 50, right? Because this is not conditional. PM and S. Okay, this means the probability among all people. What is the probability those two conditions satisfied? Male and scholarship. So here totally, so this here we need to consider total number is 50, right? 50 multiplied the probability that equals this number. Okay. Okay. Uh, oh, here we already use this some formula, right? So here we have this formula here PA, so no condition, right? So this means we just check probability for this thing happening for all people, all situation, or all people. So suppose for all we split all here, this is B1, this part is B2, this is B3, B4 like that. Okay, B3, so B4. We suppose like we split all into parts. Then we have this. Then like check B1, check B2. Okay, check B1 this thing happening, B2 this thing happening. Then should multiply. What the chance you like we just check it out. What the chance you go to B1? Then check those B1 it happen. So then go to B2. What the chance you go to here? Or what's the percentage? For this thing happening. Or we also can say that B2 contribute how much? B1 contribute how much? So those are probability. Those also can the percentage or contribute how much. Like some people, this part contribute 20%, this part contribute 80%, right? So like that. Okay. Okay. So for independent, usually we use this because it's simple. So this one and this A equal PA on the B, O equal PA on the B bar. So here's the definition: A happen or B happen or B not happen doesn't matter. So this A and B are independent. But I compare these two formula. We usually prefer this because this looks simple, right? Okay. Okay. So for two factors, we usually use we can use a table. Okay. So here B should B bar like so I cannot type B A bar. Okay. So here just the A. So we have two factors A and B. So A or A bar or B bar, right? So we have such a table. Okay. So suppose total we just put O as 1. Then this means like 40%. Okay. So A bar is so if we split 1 into parts into A or A bar, so A 0.4, A bar 0.6. Okay. So we also know this. So what is this? 0.2. 0.2 is A and B. So now let's say we have this condition: A or B equal 0.7, A and B is 0.2, PA equal we put this information into this table. PA equals 0.4, then A bar is 0.6, right? Okay, so then what is this part? A or B? A or B? So A we have this two cells for A. B A. Oh no, A or no here A. A or B. This is A, yeah, A or B. So we just take this line A, B, this like A, this line, right? This line for A, this line for B. So A or B, we have these 3 cells. These 3 cells stand for A or B, right? So A or B is 0.7. Then this one should be 0.3, right? So now we can fill out this table, then we can answer everything. So let's say B bar, A bar. Okay, so 0.2, okay, 0.4. Okay, so this is 0.2. Okay, and this is 0.6. Okay, and this is 0.3, so this is 0.3. Okay, so we have this table. Okay, so we can answer the question. Let's say, what is this? P A on the B. So here, totally, we just check B. The B is 0.2. This B is 0.2, 0. B have 2 parts, right? So totally 0.5. So among the 0.5, how much is A? So this is 0.2, right? So what is, let's say, A, PB bar A? Okay, so we just use this notation. Oh, I'm sorry. B bar A. So this means we just check A. So A is 0. Totally is 0.2, no 0.4. So among 0.4, we have the 2 parts, like this part, this part. So this part is B bar. So B bar is 0.2, right? This part B bar, this part B, right? Okay, and then so we can, once we have this table, so we can answer everything. So here A, let's say what is this? A and B bar. So A, where is A and B bar? A and B bar 0.2, right? Okay. Okay. So let's say for this problem, let's say we have this and this. So for, let's say, for 2 factors, we can use the table. A bar, A bar, B bar, we can draw a table. So fill out the information we can find. And we also can use Venn diagram. Okay, so suppose like this is for A. So this is for A. Okay, and this is for B. So suppose this stands for B. So what this means among among those, A count for half. So this means like suppose this part, okay, so this is A, right? This part and this part the same. Suppose so we put X here, then this is also X, right? This means PA on the B is 1/2, half. Okay, so then what is this? Among A or B, A count for 2/3. So among A or B, this A or B, so this part A or B. Let me change the color. Okay, got confused. Okay. So let's say, so A, so this is A, I'm sorry, A or B. So A or B, so this is A, right? So A count for 2 over 3. So suppose this x, so we know this also should be x, just like that, right? So we say like we have like split 3 parts. So A count for A among, so A or B 3 parts, x. Okay. Okay. So now let's say, so there's a condition. A and B are independent. So we have thus independent means PA and B equal PA times PB. So apply to here. So suppose totally is 1. Then P, A and B is x. Right? This A and B is x. PA are 2x. PB 2x. Right? So we get x equal, cancel 1x, cancel 1x, so x equal 1, equal 1 over 4. Okay. Yeah, so we say this is 1 over 4, this is 1 over 4, 1 over 4. So other side is also 1 over 4. So what is A and B? A and B, so 1 over 4. Okay. So from textbook, so we also have this, they are emphasize the formula of A or B equal PA plus BB, so minus this, O equals this. So A or B, so we can use, so A or B just A plus B, but this overlap A and B, we counted twice, so we should minus, right? So for this formula, so we can use this formula. Also, we can use like a Venn diagram. Okay. So for such a problem, we can use a formula. Also, we use a table. So let's say, okay. So we're talking about what is talking about get the internet what is 60%. So here we say maybe we talking about internet or not internet, no internet. Okay, so this is 60%, so 40 no no internet service, right? And also we're talking about the television service. Yeah, so television service or not, no television service. So television service, so total is 80, saying not 20. So we suppose that totally 100. We can use those. Okay, use those table. Okay. Okay. So what is this? 50% get both service. So both services, this is 50. Okay, so this is 10, right? So this is 10 and this is 30. Okay, so we can have this table. So what is the A? What is the problem? What is the question? Get at least one of those services. So this means like P, okay, get television service or internet service. So we say this equal just equals this plus this plus this, right? This is 3. Okay. So here we don't need to use this formula. We say just there's 3 means A or B. Like only this. So what this means? There's 10%, meaning there's 10%. So no any service, right? Okay. Okay. So we talking about separate all into parts by one fact, or by 2 fact, or by many fact. Okay, so how about 3 factors? So 3 factors, so the situation become quite complicated. So we can only consider a very simple case. Like each fact has only 2 levels. Like A or A bar, yes or no, yes or no, yes or no. So for 2 factor, we can consider male, female, or we also can look at a female is not male, just male M or M bar. But the grades we can consider A, B, C, D, E, right? So for those things, 3 factors. So usually for 3 factors, usually too complicated, so we can only consider this case. So totally, how many cases we say like we can have? Suppose we use A, B, C, A, B, C. So A we have 2 levels. Yes or no, yes or no, yes or no, or A or A. We just put 1 or 0 for E. So we can have 8 cases, right? So we can use this like could be all are yes, 1, 1, 1, or 1, 1, 0, or 1, 0, 1, or 0. So we say like 1 is yes, 0 is no, right? So we can also use this way. Okay, 1, 3, 1, so 1, 0, and 2, 0. Okay. And 3, 0. We also can use this. We can split it into 8 cases. And we also can use Venn diagram. But many people just prefer Venn diagram. Like this, like here, we say, we have 3 things like strawberry, or blueberry, or grape. So some people, so here, some people like both of them, some people like one of them, some people don't like any of them, like that. So here we have 3 factors. So we try to split 3 factors, split people by the 3 factors. Okay. So for such a problem, so suppose we say this is part of a strawberry, this is blueberry, and this one for grape. So we put those information into this Venn diagram. So we just check this part like or. So 3 like or. So we put 3 here. This part means like all of them. So 4 like none. So other side is 4. Okay. So we just check this. So we need to go like backward, like 20 like blueberry and grape. Let's say, so where is blueberry? Blueberry and grape. This part, right? This part. So this part is 20. So we already have 6 here. So we put this is 14. Okay, then 17 like strawberry and grape. So this part is 17. Like this part is 17. So we know this is 11, right? And 9 like blueberry and strawberry. So we have 6 here, so this is 3, like that. Okay, so now 39 like grape. So 39 means this is 39. Okay, so we already have 6, 14, 11. We already have 31, right? So we know here is 8. So we just do this way, so we can fill out each cells. Or then we can find the question how many kids. So we can find the total numbers. Okay. Okay. So we say if we separate all by parts, we can separate all by 1 fact, or 2 fact, or 3 factors. So 3 factors is too complicated. So we can only consider yes or no. Okay. So similarly, like we can consider like 1 fact, but 1 fact have many levels. We can say like male, female. We just separate people by 1 fact, gender. So we only male, female. But if we separate people by their age, then we can have many groups, like young people, old people, or teenage, or so we can separate many, right? So here we say we can check. We need to check each part. So here check each part, and also we can say check each case. Suppose when we consider any questions, when we consider something, we should check all situations. So this formula is just to check all situations. Right? Okay. So consider all conditions. Okay. So let's consider the problem. Suppose you have 2 bags. Let's say bag 1, bag 2. For bag 1, we have 70 red one and 30 blue one. For this bag 2, we have 60 red one, 40 blue one. Okay. So now suppose like you pick 1 marble from bag 1, pick 1, then put it to here, then you pick 1. From bag 2, pick 1. Now you pick 1 from bag 2. So what is the probability that you get a blue one? What is the chance? What is the probability that this one is blue one? Okay, so we say totally we have 101 because 100 plus 1. So we know the denominator, but we don't know the numerator. So how many blue one? 40? Or could be 41, right? So here we have 2 cases. We should consider each case. So if this is 40, so this means the one from bag 1 is lead 1. So what is the chance this thing happen? So we say this get this one, the one from bag 1 is lead 1. So then in bag 2 we still have 40 blue 1. Okay, or if we have 41, this means from bag 1 we picked a blue 1. So such a chance is 30 over 100. I'm sorry, here's 101, right? 101, yeah. Okay. So this is a very general idea. We should consider this case, that case. Like check each case. Okay, so those are probabilities. So if we, so probabilities, what is the chance? Like this case, case 1, what is the probability, right? So case 2, what is the probability? Case 3, what is the probability? Okay, so we can put those all probability together, and we denote this 1, 2, 3, case 1, case 2, case 3 by some by a random number variable. We say x equal 1 means case 1 happen, x equal 2 means case 2 happen. So we call such as distribution, and this is we say the discrete distribution, right? X can be 1, x can be 2. So here x equal 1 means not this number is 1. We say this thing happen, right? X equal 1, we can understand the x equal 1 means case 1 happen, right? Okay, so we have many those discrete distribution. So we will check some typical distributions: binomial distribution, or geometry distribution, or negative binomial distribution, or Poisson distribution. So those are most important discrete distribution. So I'm sure you already know binomial distribution, right? Because in I think in many courses we will mention binomial distribution, like in over Math 3546 we mention binomial distribution, right? So how about other distribution, like binomial distribution? So we should know those things, like those scenarios for those distribution. So binomial distribution typical example is just for a standardized exam, like multiple choice questions. So we have 20 questions. If you randomly pick your answers, how many questions you can answer correctly. So those things we can say, like, you try n times for multiple choice questions. So for those questions, suppose you don't know the answer at all. So question 1, question 2, no difference, right? So for your job, it's just from A, B, C, D, E, you just pick one, right? So we say, like, you just do the same thing. Just from A, B, C, D, pick one, A, B, C, D, pick one, right? So you try n times. We want to find how many times you get a success. So this number is this x x equal 1, could be x equal 2. So this random number followed binomial distribution. Okay, so we say this is x followed by binomial distribution. So what is geometry distribution? Geometry distribution is just like you try keeping try until you get it, until success. Like you shoot a target. If first time failed, then try second time, then try third time, like that. Okay, so we put the landing number. So how many times you need a shot to shot you need shooting in order to get the target. Okay, so this number can be, if you're really really good, just 1, right? First time you hit the target, or you need 2, like x can be 1, or maybe need 2 times, or maybe need 3 times, or 4 times, or logically or mathematically. So this number can be from 1 to and until infinity, right? So those are geometry distribution. So for negative binomial distribution, so I don't, this name I don't know where the name come from. So this is for geometry distribution. You can stop if you get the target. If you hit the target, you stop. So let's consider a little bit general. Suppose like you can stop when you hit the target twice, or three times. So you can stop trying. You can stop shooting until success. Right? Hit the target 3 times. So this x, how many times you need to shoot? X at least should be r time, right? So r time means r time each time you hit the target, or r plus 1, or r plus 2 until infinity, right? Okay, so this is negative binomial distribution. Okay, so the other one is a Poisson distribution. So those distributions are about like how many things, like how many times something happened during a certain time. So for example, like I'm sitting in my office. So I wanted to know in 1 hour how many people will stop by my office. So this could be 0, right? Nobody visited my office. Or could it be 1? Or could it be 2, right? Or could it be 3? Or could it be infinity? So such things follow the distribution called Poisson distribution. Okay, so Poisson distribution also have many applications. Like for example, like we wanted to estimate, like suppose like we wanted to know how many car accidents will happen in 1 week. So this number can be 0, no car accident, 0, right? Or could it be one car accident in 1 week, right? In so there's a time, fixed time period, right? Or two, right? Or three, right? So those are Poisson distribution. Okay. So the first, for the questions, so you should know what the distribution is for such, for typical problem. Okay. Okay. So now, so we have the formula like probability, like let's say for binomial distribution, maybe this one we are quite familiar with, like P equal K among n trials, K times good thing happen or bad thing happen. So this equal happen, this thing happen, like we say good thing success, we just say this thing happens P, probability P. So P happen K time. So not happen Q happen remaining ones n minus K. But so here the coefficient that come from like so we say like good thing happen K time. So could be this K or could be that K. Like we saw, we just from n positions, we just choose K positions. So this is just from n people, choose K people. So how many ways? From n choose K, right? So for distribution, so we have those things like mean and variance. Mean, so we say we can call it means expectation, right? So X. So means average. So here average is NP. So we say for P is a good thing happen, probability. So if we try one time, such a thing happen is P. If we try n time, so such a thing happen NP. Like this NP is, you can expect NP will happen. So for example, if for multiple choice question we have ABCD, so each question has 4 choices. So P is 1 over 4. So this 1 over 4 means among 4 trials you can get 1, right? So if you have n trials, so you just can get n times P, 1 over 4. Like for example, if we in this exam we have 100 questions, so you try 100 times. So each one, the probability good thing happens 1 over 4. So this means among 4 trials you can get 1. So 4 trial 1. So 100. So 100. How many 4? So 25, right? So you can likely get 25 question correctly, okay? Or 25 points. Suppose each question 1 point, okay? So here we don't. So here we just how can we get this formula? We need to use some math. We need some math, but here we don't. Maybe we should memorize this. Remember them. So for geometry distribution is like so Px equal K means you need K time for short. So this means you fail n minus K time. Then last one you hit the target, right? So this equal probability Q means fail happen n minus K1. Then last one is P. Okay. So that what is so this is EX average. How many, so you can, how many times you need, how many times shooting you need to hit the target. So, let's say, so the probability is a good thing is P, suppose P is 0.1. So what this means is 0.1 means 1 over 10 means among 10 trials, among 10 shot, let's say we just put the 10 shooting, you can get one target, right? So, so this means like here, what is the average? The EX, so EX is the average number of your shot. So this equal 10, right? So this equal 1 over P. Okay. So negative binomial distribution, we just multiply R. Okay. So here R multiply 1 over P. So variance multiply R. So this one, I'm sorry. So this one, what does this mean? So we can say you need a K, let's suppose X equal K means you need a K time try. Okay. So here, so this means you already success 1 minus R minus 1. So then last one you should hit, right? So total is R. Okay. So here, so among those K trials, so you can be this R minus 1 or that R minus 1. So how many ways? K minus 1. So we see, we just put here K minus 1. We just check like this previous one. Among the K minus 1, so you should pick, use this R minus 1, so for success. R minus 1, so success. So total success is R time. Saying not success, K minus R. Right? Okay. Okay, so for Poisson distribution, so we just use this formula. Okay, so Poisson distribution, how can we get this E? So E always use relative limit. And E, what is E? So E equals this limit. One plus 1 over n. So we usually denote this as 1's infinity. Okay. Let n goes to infinity, right? Okay. So this formula, we need some math. So let's say, as application, we just need to use the formula. Okay. As mathematics, maybe we need to know how to get the formula. So this depends on our needs, right? Okay. Like for, let's say, if you focus on actual exam, you just use the formula. Okay. Okay. So we can have some examples. So for those examples, most important thing is what is distribution, binomial distribution or Poisson distribution. You should determine this. Okay. Okay. So for this one, let's say, if the medication is given to 10 new patients, what is the probability that exact 7 is effective. So this is like for 10, among 10 good things happen 7 times. So this is binomial distribution, right? Yeah. Okay. Okay, so this is also binomial distribution. We have 5 patients, and those patients could die, right, or not die, right? So this is binomial. Okay. Okay. So let's say like a number of toys is to first head. So you just keep doing. You can stop. Here we're talking about first head. So this is geometry distribution. So x equal 5. So meaning like you need 5 times. So you means the previous 4 times fail, or the head not appear. Tail. Then last one head appear. So this is geometry distribution, right? Okay. So let's say x number of inspection. So you just always keep inspect. So when so to when so to obtain first. So here the keyword first defective. So the story is just the key. You keeping inspection until you find a bad one. So this is geometry distribution, right? Okay. So this game, there, let's say, this game they want to let's say wanted to determine who will win. So usually like so usually we have fixed time for playing, right? Like we could, let's say 7 times we determine who is the winner, or 3 times we determine who is the winner, right? But here we the winner is, let's say the winner is the one whose point become 2. So if win got 1 point, lose get a -1. So for A, like for me, like first one I win, so I get 1. Second one I also win, then I got 2. So I win. So also could be the first one I win, then second one lose, then I become 0, then lose, or then win. So here, those things can always keep playing, right? So those things, just like we say, those things are geometry distribution. Only something happen, we can stop. If something not happen, keep doing, right? So those are geometry distribution. Okay. Okay. So for this one, this one already tell us Poisson distribution. So you in a given week, how many policy you will sell? So if you are insurance salesman, we just says like if you sell 1 policy, so the good thing happen. So here during one week period, how many good thing can happen? So this is Poisson distribution, right? So it's a Poisson distribution. Okay. Okay. So here already tell us there's a Poisson distribution. Yeah. Okay. Okay, so we can stop here. So we say this maybe, I think you already know those materials. So this we can regard this as a review. Okay, so we can stop here. Thank you.